Namaste, Mata, Pita, Guru, Deva. Welcome back to Pine IT Edu Plus. Today's topic Basics of Linear Regression. Basics of Linear Regression in Python. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. The goal of linear regression is to find the line that best fits the data. Simple linear regression. In simple linear regression, there is one independent variable triple x and one dependent variable triple y. The relationship between triple x and triple y is modeled by a straight line. Next is multiple linear regression. Steps to perform linear regression in Python. Let's go through the basic steps to implement linear regression using Python. Load data. For this example, let's use a built-in dataset from Seaborn or Pandas to perform a simple linear regression. Prepare the data. Before fitting the model, split the dataset into features and target. Split the data into training and test set. This step ensures that we evaluate our model on unseen data. We split the dataset into 80% training data and 20% testing data. Create and fit the model. Now we create a linear regression object and fit the model on the training data. Make predictions. After training the model, you can use it to make predictions on the test data. Evaluate the model. To evaluate the model, we can calculate performance metrics such as the mean squared error and the R squared value. MSE gives you an idea of the average error between the predicted values and the actual values. R squared tells you the proportion of variance in the dependent variable that is predictable from the independent variables. Visualize the results. You can plot the regression line along with the actual data points to see how well the model fits. Multiple linear regression. When you have more than one independent variable, you can fit a multiple linear regression model. Model building in Python an overview. It is the process of selecting, training, and evaluating machine learning models. It involves preparing data, choosing appropriate algorithms, training the model, and evaluating its performance. In Python, popular libraries like scikit-learn, TensorFlow, and Keras are commonly used for model building in machine learning. Here, we will focus on a simple workflow for building a model using scikit-learn, one of the most widely used libraries for machine learning in Python. In the following steps, we will cover data preparation, model selection, training the model, model evaluation, and model tuning and optimization. Data preparation. Before building a model, the data must be prepared. This includes loading data, handling missing values, encoding categorical variables, and splitting the data into training and testing sets. Loading data. You can load a dataset from various sources such as CSV files, Excel, or even built-in datasets from libraries like scikit-learn. For example, we will use the iris dataset, a classical dataset for classification. For instance, if your data contains categorical variables, you can encode them using techniques like one-hot encoding or label encoding. Splitting the data. The dataset is usually split into training and testing sets to evaluate the model's performance on unseen data. A typical split is 80% for training and 20% for testing. Model selection. Choosing the right model depends on the nature of your data and the problem you are trying to solve. Common models include classification, logistic regression, decision trees, random forest, support vector machines, k nearest neighbors, etc. Regression, linear regression, Lassa, ridge, decision trees, random forest, etc. Training the model. Training a model involves providing the model with the training data, and the model learns the relationships in the data to make predictions. Model evaluation. Once the model is trained, you need to evaluate how well it performs on the test data using performance metrics. Common metrics includes accuracy, precision, recall, F1 score, confusion metrics, mean absolute error, mean squared error, R squared. For classification problems, accuracy is often the first metric to check. Model tuning and optimization. To improve the model's performance, you can tune hyperparameters or try different models. Some common approaches include hyperparameter tuning. You can use grid search CV or random size search CV to search for the best hyperparameter for the model. Nonlinear regression in Python. It is used when the relationship between the dependent and independent variables cannot be described by a straight line. Instead, nonlinear regression models the relationship using a more complex nonlinear function. Steps for nonlinear regression. Understand the data, choose a nonlinear model, fit the model, evaluate the model, visualize the results. First one is understand the data. Second is choose a non-linear model. Third one, fit the model. Fourth is evaluate the model. Fifth one, visualize the results. Conclusion. Nonlinear regression allows us to model relationships where the dependent and independent variables are not linearly related. In this example, we used exponential regression to fit a nonlinear model to synthetic data. Data preparation, model selection, model fitting, model evaluation. Line estimation or linear regression in Python. It is one of the most common statistical method for modeling the relationship between a dependent variable and one or more independent variables. It estimates the line of best fit that minimizes the residual sum of squares between the observed values and the predicted values. Steps for line estimation. Load the data, visualize the data, fit the model, evaluate the model, make predictions. We will demonstrate simple linear regression first and then extend it to multiple linear regression. Conclusion. Line estimation through linear regression is a powerful method for modeling relationships between a dependent variable and one or more independent variables. In this guide, we demonstrated simple linear regression with one independent variable. We extended it to multiple linear regression with multiple independent variables. We used scikit-learn to implement both models, evaluated them using mean squared error and R-squared, and visualized the results. Linear regression is widely used in many applications including economics, business forecasting, and machine learning. It's important to ensure the assumptions of linear regression are met for reliable results. Applications of regression and logistic regression models. Both regression and logistic regression are widely used in various fields to analyze and predict data. While regression models are used to predict continuous outcomes, logistic regression is used for binary classification problems. Below, we will explore some key applications of both types of models in real world scenarios. Applications of linear regression. It is used when there is a linear relationship between the dependent and independent variables. It is powerful tool for predicting continuous outcomes. House price prediction. In real estate, linear regression is often used to predict house prices based on various features such as square footage, number of bedrooms, location, age of the house. Example, the relationship between the price of a house and its size is often linear, and the linear regression can estimate the expected price based on size. Sales forecasting. Linear regression models are used to predict future sales based on historical data. Independent variables might include advertising budget, store traffic, seasonal trends, prices of competitors. Example, a company might use linear regression to predict sales in the next quarter based on previous month's advertising spend, seasonal effects, and economic indicators. Stock price prediction. Linear regression can be used to predict stock prices based on historical data. Factors including stock prices, such as interest rates, company earnings, or macroeconomic indicators, can be used as independent variables. Example, a financial analyst might use linear regression to estimate the future price of a stock based on its past performance and economic factors. Medical cost prediction. Healthcare providers may use linear regression models to predict the medical costs of patient based on factors like age, body mass index or BMI, smoking habits, pre-existing conditions. Example, a health insurer could estimate the medical costs of a policyholder based on their age, smoking status and BMI, helping them set premiums. Applications of logistic regression. Logistic regression is used for binary classification problems where the outcome variable is categorical, typically with two classes. It predicts the probability that an event belongs to a particular class. Customer churn prediction. In customer relationship management, companies often want to predict whether a customer will churn or stay based on various factors like customer service interactions, subscription plan, length of stay with the company, purchase behavior. Example, a telecommunications company might use logistic regression to predict whether a customer will cancel their subscription based on their usage pattern, customer support calls, and other features. Fraud detection. Logistic regression is widely used in fraud detection for financial transactions. It predicts whether a transaction is fraudulent or not based on features such as transaction amount, time of transaction, location of the transaction, past behavior of the customer. Example, a credit card company might use logistic regression to detect fraudulent transactions, predicting whether a transaction is likely fraudulent based on the transaction data and historical trends. Medical diagnosis. In healthcare, logistic regression is used for diagnosing diseases or conditions. For example, it can predict whether a patient is likely to have a particular disease, example, diabetes or cancer, based on features like age, blood pressure, family medical history, lifestyle factors. Example, a doctor might use logistic regression to predict whether a patient has a certain disease based on their medical history and test results. Email spam detection. Logistic regression is often applied in spam detection where the goal is to classify emails as they are spam or not spam. Features could include email content, sender's email address, frequency of links or attachments, subject line. Example, email providers like Gmail or Outlook use logistic regression to classify incoming emails as spam or not based on the content of the message and the sender. Loan default prediction. Financial institutions use logistic regression to predict whether a borrower will default on a loan based on features like credit score, income level, loan amount, employment status. Example, a bank might use logistic regression to evaluate loan applicants and predict whether they will default on their loans, helping to decide whether to approve or deny the loan. Key differences between linear and logistic regression. Linear regression. Outcome variable continuous. Goal predict a continuous value. Function. The model predicts the value of dependent variable using a linear combination of independent variables. Application examples: stock prices, sales forecasting, temperature prediction. Next is logistic regression. Outcome variable categorical. Goal predict probabilities that the outcome belongs to a certain class. Function uses a logistic function to model probability that the dependent variable belongs to a particular class. Application examples: email spam detection, medical diagnosis, fraud detection, churn prediction, etc. Conclusion: both regression and logistic regression are powerful tools with diverse applications. Linear regression is best suited for predicting continuous outcomes such as sales forecasts, stock prices, and housing prices. Logistic regression is ideal for classification problems such as predicting customer churn, fraud detection, disease diagnosis, and email spam filtering. By understanding the nature of the data and the problem at hand, you can choose the appropriate model to make accurate predictions. That's all for today. We hope you found this tutorial informative and helpful. Detailed PDF notes available. Pay just Rs 49. Share the screenshot with video name and we will send you the notes. Google Pay number is given below. We are also providing online and offline classes on Oracle or MySQL SQL, PLSQL, Python Basics, and Python Advanced on all days from 4 am to 10 pm. For more details, please contact Mrs. Santhu Dinesh +91 9747006133. She will be available on WhatsApp also. If you have any feedback or suggestions for future videos, please let us know in the comments below. Your support means the world to us. For more videos and tutorials, please visit our channel Pine IT Edu Plus and subscribe. Don't forget to like, share and hit the notification bell. Thanks for watching and we will see you in the next video. Bye.